Hi, I'm Pat. All right, what they tell us to do in this problem is to treat this theta as the acute angle of a right triangle and then use this indicated function value in order to find this other trigonometric function, and they tell you to use the Pythagorean identity, or the appropriate version of one. So, let's see. First of all, using that theta as the acute angle of a right triangle, maybe a quick sketch for yourself. And when they say to let the theta be an acute angle, that just means one of these corner angles, like here for theta. And you actually can't get it wrong if you went to the other one and called that one theta. That's not what's important, which one you call theta. Here's what's important, is that if I wanted to look at this as a fraction, 0.8 would be my numerator. And I can always put a denominator of 1, right? So back to the drawing, what's important in terms of the angle that you do label theta is now just make sure you're getting your opposites and your adjacents accurate. And so what I mean here is 0.8 in my numerator would be the opposite side of that triangle, and the denominator of 1 would be my hypotenuse. This is like our y over r from the definitions of our trig functions, right? So the hypotenuse, or the radius of the circle that this would be put on, is 1. Okay. Now, they also mentioned to use the Pythagorean identity and the version of it that's appropriate for the given problem. And what that means is our Pythagorean identity, one of them is sine squared plus cosine squared equals 1, right? Sine squared of theta plus cosine squared of theta equals 1. That's the one that I would want to use for this problem because they give me a sine and they're asking for a cosine, okay? And a different problem that you're probably going to work on is they may give you a secant and also ask for tangent. So use the other version of the Pythagorean identity that has secant and tangent in it. Maybe they give you a problem where there's cotangent and cosecant involved. So use the appropriate version of the Pythagorean identity. For us, as I mentioned, the one we're going to use is sine squared of theta plus cosine squared of theta equals 1. And we're using that one because sine is given to us and they're asking for cosine. So let's see. Sine is given to us. That was the 0.8. So 0.8, don't forget that that's squared in this identity, plus cosine squared of theta, which is kind of what I'm looking for, right? Kind of only because I'm going to have to do a square root, equals 1. Now it's algebra, and there's a decimal involved. You can grab a calculator if you need to. This one's not too bad. 0.8 squared would be 0.64 plus cosine squared of theta equals 1. Cosine squared of theta equals 1 minus 0.64. So cosine squared of theta equals 0.36. And I'm on a roll. I think I could do this without a calculator as well, only because the numbers are kind of nice. I can square root both sides and get cosine of theta equals 0.6. You might be remembering that's a plus or minus, right? But we only want the positive one of this because it's on a right triangle, and so that this represents the one side, and our lengths are going to be positive. Okay, hope that helped. Try some on your own.